So, hello everyone. Good morning, authors and invited guests. Today, to technical session 1C, myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2024, Pune, India. The eighth edition of the conference is being organized in a hybrid mode. The physical event is organized today in Pune, India, and the virtual event is being hosted through Zoom today and tomorrow, that is 12th and 13th of January 2024. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation, 2 minutes for question and answer round, and on 7 minutes, I will put a reminder. There is another request to all the participants that you all stay connected with us till the end. If you have any query or update, then let us know or write me us in the chat box. So just before we get started, I would like to introduce you with a session chair. So for today, the session chair is Dr. Ruchi Nanda, Associate Professor and Head of Department of CSIT, IIS Deemed University, Jaipur, India. Dr. Ruchi Nanda is working as an Associate Professor and Head in the Department of Computer Science and IT at IIS Deemed to be a University, Jaipur, India. She has actively contributed in teaching and R&D for the last 17 years. Areas of interest and research are in big data, cloud computing, machine learning, and database. Ma'am, I would like to call Dr. Ruchinanda ma'am to say some words.
Hello, namaskar everyone. Maybe I got disconnected. Sorry for that. Yes, thank you, Mr. Amit Joshi and the entire GR team for inviting me as session chair. And I wish all the best to all the participants. And please stick to the timings as given by, as stated by Mr. Hirsch. All the best to all of you. I think we can start now.
Thank you, ma'am. Now I'm starting with the first presentation by Akash Tambre for his research work, a collaborative coding platform for both college students and teachers. Mr. Akash, you can start with your presentation.
Yes, sir. Okay, can I start?
Yes, sir, you can.
Yes, you can start.
Hello, everyone. All the
Thank you.
authors and the dignitaries present here. Good morning to everyone. I am Akash Temre, representing my research on a collaborative coding platform for both college students and teachers. And on behalf of my team members and my guide. So we have named the coding platform as a Code Connect. So let us go through table of content. In this presentation, I'll be telling the aim and objectives of my research work, the introduction to the software, the web application, the methodology used, the workflow which is used in the web application, and the result of the application, also the conclusion and future scope of the application. So the aim of our Code Connect platform is our Code Connect platform aims to provide an integrated coding platform for practice learning, evaluation, and improvement of both student and teachers in the college. We aim to provide a holistic education experience that benefits both college students and teachers in strengthening the computer science education. the main objectives of our application is like facilitating the skill development that both beginner students and teacher can experience the interactive coding sessions and practice session. Our second objective is to provide accessibility and convenience for the student to practice the code from anywhere and anytime with proper guidance and suggestions. Also, building a community is also a motive where a particular college or institute, in particular college or institute, all the students and teacher will come together and practice coding and evolve themselves. So let me introduce my a web application, which is Code Connect. It is a coding platform. Like we all know that traditionally there are various coding platform available, but we don't know who is posting the questions and who is going to review our question. So this application is purely based on student-teacher interaction, where teacher will upload the question for the student. Also, the student will be getting extra questions for practicing, and the questions uploaded by the teacher will be attempted by student, and the teacher can evaluate them at the same time. The Code Connect offer the role-based registration, where we provide two kind of registration. One is of student and one is for teacher, where student can not access to various accessibility like teacher can have. So we provide a powerful dashboard which represent how many questions the student practice and how many how many questions the teacher has uploaded and how many of them are reviewed. So our Code Connect aim to overall provide challenges and improve the students' coding skills and abilities. So the methodology used in the coding platform is at the first place there is a web application, which is hosted on web server. The student and teacher, which are user, they send the request through. Let me move toward the diagram. The student and teacher, which are user, they send their request to web server for accessing the data, and the authentication plays a main role, which decides that teacher has to do it, or student has to log in this. So on the web server, it provide a user-friendly interface where a student can find various blogs like questions, question posted by teachers, and which are segregated into categories of various languages. And then the request is forwarded to the compiler API, where the compiler API is a third-party API which is used here, in which the student can run the code and submit the code at the same interface. And the compiler API is integrated with 20 plus coding languages. And all the data is stored in a database, which help us to remember and relog in the user. So let us talk about the workflow of like front end, in which the student and teacher login and sign up are involved. Like the login and sign up goes through the web application, where the student and teacher get login interface, and then after login, the authentication works on the back end, which tells like your student or teacher, and accordingly it assign you the interfaces. Like if you are student, it will fetch all the questions and categories, provide you the coding compiler, and gives you the button to run and submit the answers, and also display the result and reviews by the teacher, which have been given by a teacher to the student. And if you are a teacher, it will provide you a interface where it gives you a dashboard where you get to know how many questions a teacher has uploaded and how many of them are solved by the students. And also the teacher can add questions, categories to the questions according to languages. At the back end, the request is
7 minutes has
request.
passed.
Sorry.
7 minutes has been passed out.
Okay. So at the back end, all the authentication and database operation are been going on at the same time. So these are some of the result which I would like to share. This is a student interface where student get such a dashboard where this color configuration shows that how many questions have been answered, how many of them are right, and how many are in reviews. This is the interface where student get to know get the questions and compiler at the same time. This is a resizable compiler. The languages are provided here like languages and theme is available here. Over 20 plus languages are available in that. And also this is a teacher interface. A number of questions uploaded, how many of them are answered, and how many categories are been created. Categories are according to languages. This is the page where a teacher can create new questions. And this is the page where the students answer are visible and the comment can be provided with the score to the student. So in conclusion, our design is implemented on web. So it is a coding platform which mainly focus on the interaction between teacher and student, and provide a community within the college and the area. Thank you so much.
Any questions?
Okay. Is this a part of your some course or something?
Sorry,
Is
ma'am.
this project is a part of some course?
No, ma'am, it's not a part of course. We had a final year project, so we have to create some um, new work. So like in our college, there was no personal coding platform, or we have to all have to depend on third party application. So
Okay.
our main motive was to create a coding platform for our college, which can be used by various event when the coding event occurs in our college. So it can be used at that time.
Okay. You are from which college?
I am from GS Raisoni College of Engineering, Nagpur.
Okay. And how do you think it is different from the other applications that are being provided by third party?
Yes, ma'am.
Yes.
This is like a question which we have to tackle in this application. So accordingly, like there are various applications available on the internet, but this is like your teacher has to assign some work to your particular student. So a teacher from your college have to give you some work, and you have to take a guidance from a particular teacher. So like in most of the application, one-to-one sessions are available, but they are very costly and paid. So this is the main motive, that to provide a better solution, or like a free of cost solution for a mentor and a student.
Okay. When we talk about the local, right?
Yes,
When we
ma'am.
talk
Yes, ma'am.
about the usage of this software locally in your college.
Yes, ma'am.
Yeah.
At the first page, our idea was for a local use.
Yeah. Okay. Thank you for your
Thank you, ma'am.
presentation. All the best.
Thank you, ma'am.
Next.
Now would like to call Devadrishi for the research paper, a review on suspicious behavior detection at heritage sites during quantum enhanced deep learning.
Yeah, can you hear me?
Yes, you can start with your presentation.
Yeah. Can you see my screen?
No, ma'am, it's not visible.
Okay. Can you see it now?
Yes, ma'am, it's visible.
Yeah. Okay, good morning everyone. Our review is on suspicious behavior detection at heritage sites using quantum enhanced deep learning. So, why heritage sites? So, heritage sites are the wholesale culture of everyone's past, and it bridges between the past and present. So we are choosing heritage sites, and heritage sites are more likely to be distracted, destroyed, and there is a lot of crowd. So there is a lot of chance for a suspicious behavior and other things. So the heritage sites face threats like vandalism, fight between peoples, and theft of important valuable products and unauthorized access, damaging the sites and impact the tourist experience and endangering visitors. So because of these actions, the visitors will be feeling unsafe. So we are detecting it using a quantum enhanced deep learning so that to avoid these actions. So, what are all the suspicious behaviors? Unauthorized access, accessing into a restricted areas where there is no access to person, and unattended bags and packages where may contain weapons or something that is suspicious, and then photographic security measures, for being uh, taking photos in restricted areas and erratic behaviors, fights, and then unusual drone activity, which is not supposed to happen in heritage sites, and then arson, and then suspicious objects like weapons, guns, knives, and then looting. These are the suspicious behavior we are mainly focusing on. And then review on literature. We have studied a lot of papers, which includes the suspicious behavior activity recognition. They use different kind of algorithms for detecting the suspicious behavior at different regions. But mainly, we are focusing on the heritage sites, and these are all some works of the peoples which uses the long-term recurrent convolution neural network and convolution neural network, recurrent neural networks. These are all the mainly used algorithms to detect the suspicious behaviors at heritage sites, and then in schools, and then in shops. These are all the main algorithms used in this. So we are proposing an idea that is about our aim is to improve the security, swiftly detecting and classifying suspicious activity and triggering alerts. And then we use a combination of deep learning and quantum computing. Deep learning, for deep learning is used for deep learning. We using CNN and RNN. In CNN, the video is analyzed, and it will be converted into frames per second, and then it will be used to recurrent neural networks to analyze the pattern recognitions. So from that pattern, for this, we are in this method, we are implementing quantum computing. So that to increase the speed of the data processing, so that it can be quickly and swiftly detect the anomalies in that regions. So and then after the quantum computing, we are implementing a ML or algorithm to classify which is the suspicious or normal. If it is suspicious, it will trigger a message. So we are using a real-time surveillance video. In real time, the video is fed into the quantum model, and the quantum model will be evaluating the video, and it will transfer into frames, and then the pattern will be recognized using RNN, and it will be used to fed into a ML model, and then the ML model will classify it, and then it will trigger an alarm if it is an suspicious behavior. Um, okay. Uh, in previous it is all of deep learning algorithm. So in this paper we are introducing quantum computing, so that it will be fast and accurate. So heritage sites are precious places that hold our history and culture. So this heritage sites has to be protected and preserved, and our culture should be preserved. So we are proposing in this idea. So that's it about it.
Thank you, Devashtri. Ma'am, any questions?
I want to ask a question from you. Have you implemented this quantum computing,
Yeah.
or you are just proposing all these three things like quantum computing and the algorithms that you were talking about in this paper? Are you proposing, or
We planned of doing it. We started it from data collections. So we are doing it.
okay? So have you selected the data set for it?
Yeah, we have collected from UCF crime dataset, which contains wide areas of dataset and variety of datasets.
Okay, from Kaggle or some website?
Yeah, website.
Which data set?
UCF crime dataset,
Okay,
Avenue dataset.
okay, okay. And how will you implement this quantum computing?
We have IBM. IBM provide quantum models. So by collaborating with them, we can implement them.
Okay, okay. All the best.
Thank
Thank you
you.
for your presentation. Next presentation.
Now I would like to move towards the next presentation by Aniban Chakraborty for a research title, A Synergetic Integration of IoT, Machine Learning, and Flutter Technology for the Precise Crop Management.
Good morning, sir. Good morning, everyone present here. Am I audible?
Yes, sir, you are audible. You may proceed
Yeah.
with your presentation.
Let me share my screen. Is my screen visible?
Yes, sir, your screen is visible.
Okay. So good morning, everyone. I'm Anirban Chakraborty, and I'm presenting on the behalf of my team a project or a product idea which is AutoAgro, a synergistic integration of IoT, machine learning, and Flutter technology for precise crop management. So going ahead with it. So the aim of our entire project or the application that we have built is to optimize the crop yield, mitigate losses, and promote a sustainable farming agriculture. And by capturing real-time environmental parameters through IoT sensors, analyzing them using our backend technologies, using our machine learning model, and presenting them in the form of our application, which is made on Flutter, and it's completely an application which can be run on any Android interface. To summarize our purpose and aim, we have basically developed an application called as AutoAgro. We have presented this application in other competitions and hackathon as well, which has bagged multiple prizes. We have built it using three different technological parameters like IoT, machine learning, and Android technology. Basically, here is Flutter. This is the third version of our project. We are capturing real-time data for disease prediction and detection, and providing the results or providing decisions based on that disease prediction using a intuitive Android interface with multilingual support. Since currently we are from Maharashtra, hence we have only brought Marathi, Hindi, and English as a lingual support. And then we are helping the farmers to optimize the crop yield, reduce the loss, and promote sustainable agriculture. Now, moving to different aspects of our project to different technologies. First, the IoT methodology. So in IoT, we are basically taking different parameters, or we are basically sensing different parameters using different sensors like DHT11, which has been used for humidity and temperature control, soil moisture sensor, and we are also using relay for water pump control, and backing up all the data in the Blink cloud and accessing the data from Blink cloud to our website as well as our application. The core of our entire IoT is the ESP8266 microprocessor, which acts as a CPU in controlling all of this sensor and backing up the data to the cloud. Going to the main USP of our project, that is the ML, the machine learning. So the machine learning is been built using a data set. We have taken the data set from Kaggle. It consists of around 54,000 images approximately of different plant diseased as well as normal healthy plants, and it has overall 32 different categories of plant disease as well as 16 different species of plant. These images are loaded and resized using the data augmentation technique and OpenCV technology. Furthermore, we have used the Inception V3 model. We could have used other. There are other models as well, like ResNet and VGG16, but they are heavy on Android application. Hence, we focused on using such a model which would be lightweight, which won't prove much of a weightage factor or load factor for the Android application. And we went with the Inception V3 model, which has the accuracy as well as its lightweight. Furthermore, we have set up multiple dense layers of radio activation as well as softmax layer for multi-class classification. And one of the main highlight of our project is the use of the Adam optimizer. Generally, people pass the data set to Adam optimizer to optimize the performance. But here we have in the algorithm added or integrated the Adam optimizer such that with the use of the product, it will increase the optimization, it will increase the performance accordingly. Till now, we have been successful to achieving a performance highest performance rate of around 99.47%. Now the our Android application basically starts with a branding page. Then we are also taking the user data. We have the capability of data analysis, managing the users, depending upon the software services or the IoT services they are utilizing, as well as the machine learning services they are utilizing. We can charge them as well. We have a secure sign up and login. Then our dashboard. Our dashboard provides different services. The first, as you can see in my left of the screen, the first one is the machine learning platform, where you can either upload the image from gallery or camera and press on the detect to detect the disease. Furthermore, you can also use the IoT, where you can see the measures of the IoT devices. Then you have the different service pages, that what are the services we provide, and the weather pages, that in the local area what's the weather right now and what will be the weather prediction. So moving on to the results that we have accumulated, we trained and tested our model vigorously to attain different classes or to attain different performance parameters. And on the left, you can see the scaled image representation. We used scale image because we did not wanted the model to perform poorly because of different dimensions of the image, and hence we convoluted this image into specific parameters, and you can see the confidence rate of each and every. And on the right side, due to the Adam optimizer, you can see the training and validation accuracy, which generally goes slanting or which generally goes constant at a point. It keeps on increasing after 0.86, and the loss also keeps on decreasing. Now I will show some comparative study that why are like this is not a first time research. This is already in being into the market, and we have compared our product with the other governmental products that are available. So comparing it with the e-Nirog app by IIIT Bhagalpur, government of Bihar, as well as iCar, we have comparatively less image parameters as compared to iCar, because they had custom database which we cannot access, but we have the Kaggle database. Moreover, going to the accuracy or percentage, our maximum accuracy that we have observed till now is 99.47%. That of government of Bihar is around 90.5%, and that of ICAR is from 97.37%. This all data is been taken from the research paper of ICAR. Other than that, none of them generally had multilingual support except the ICAR one, but we do provide that, and ease of integration is much higher in our case as compared to the others. So
Sorry to interrupt.
Okay.
You have 1 minute left for the conclusion.
Yeah. I'm concluding it. So in conclusion, we have made a transformative solution that addresses real world problems in agriculture by integrating technology and agriculture. It provides farmers with tools they need to optimize their farming practices, improve efficiency, and promote sustainability. Other than that, the ML-based disease detection feature helps farmer to identify and prevent diseases, minimizing crop losses and maximizing productivity over a prolonged period of time, right? So that's all from my side. Thank you. And I would like to answer any question if you have it.
Okay, what is your future work? Like you have implemented these things, you have created mobile app. What are the future prospects of this?
Yeah, so the future prospect is like we went to multiple competition and we got some reviews from them. So the first one was like like farmers are already experiencing knowing the disease, right? So having a feature or a machine learning platform or a machine learning technology which will also suggest them fertilizer and like integrating or doing a partnership with some fertilizing company so that we can promote their products as well, and we can suggest the fertilizers from their company at the same time. That way we can generate revenue as well as we can help the farmer to like just select the fertilizer easily. That's the first aspect. Second is there's a problem in this application that in a big field of 5 to 4 acres, it's not possible to take a mobile app and scan throughout the field, right? So our next approach is integrating rather than just focusing or based upon the application, building an drone or scanning aerial scanning system which can just scan the images from aerial view and can detect give real-time insights for the entire field.
Okay.
Yeah.
Okay, how much data set you have taken?
Like we have utilized only one data set. It consists of around 54,000 images, and we have taken it from Kaggle only.
Okay, from Kaggle only. Then you can work on real data set also.
Yeah.
Whenever you think of creating a recommendation system, in that you will be needing some for validation purpose, the data should be real.
Okay.
In that case, you can do some collaborations.
Yeah, we also thought about that. Like ICAR generally has their own personal data set, so we can just like ask them at least if they are.
Yes, if they don't, but you can make some collaborations with them. You are in which university?
I am in J. Rasuni College of Engineering, Nagpur, Nagpur University.
Nagpur.
Yeah.
Okay, all the best. Very nice presentation.
Thank you, ma'am. Thank you for your valuable insights. Shall I stop my screen share?
Yes.
Now I would like to call Deepti Gupta for her paper title Advancement and Challenges in Deepfake Videos Detection, a Comprehensive Review. Ms. Deepti. Ms. Deepti, you are not audible.
Am I audible now?
Yes, you're audible.
Okay.
You're audible.
Yes. So good morning, everyone. My name is Deepti Gupta, and I am currently pursuing my MTech from Department of Computer Science and Engineering, Indira Gandhi Delhi Technical University for Women, Delhi. And my paper's name is Advancement and Challenges in Deepfake Video Detection, a comprehensive review. Okay, so let's move towards the introduction. Wait a second. Could you just please give me a minute? Yeah, okay. A deepfake is a type of synthetic media created using deep learning techniques. It involves the use of artificial intelligence and machine learning algorithms to manipulate or generate audio, video, or other types of content in a way that appears authentic but is actually fabricated or altered. The term deepfake is combination of deep learning and fake. While deepfake technology has many legitimate and creative applications, it also presents significant ethical and security concerns. Misuse of deepfake can lead to spread of disinformation, cyberbullying, privacy violations, and even potential threats to national security. Deepfake technology can be used for various purposes. Some common applications and examples of deepfake include face swapping, voice synthesis, video manipulations, art, and entertainment. While all these applications seem to be fine, but sometimes these applications can lead to, like already mentioned, cyberbullying, privacy violations, and even potential threat to national security. So if we look at the graph, that number of the publications done on deepfake video have increased exponentially throughout the years. Firstly, it appeared in 2018, and currently in 2023, the number of publications has increased really in a huge number. So example of deepfake, face swap deepfake is a sort of deepfake that focuses on swapping or replacing people's faces in videos or photos. One person's face is superimposed over somebody else's body in a face swap deepfake, producing the appearance that the target individual is speaking or doing things they never said or did. For example, if you look at the face of actress in the first image, she seems to be fine, but in second image, it seems like something is different in the face. Actually, what in this image we have done using deepfake is that we have taken another person's, that is Barack Obama's features and superimposed on the actress's face. And we have totally changed the face, although the other one looks that the person is old, but she's actually not. And for example, again, if we look at this is an example of deepfake reenactment, where the source face is a comedian's face and he's saying something. The expressions have been superimposed on the face of Barack Obama in real-time facial expression imprint. Okay, so deepfake creation. Deepfake creation involves using artificial intelligence AI techniques, particularly deep learning, to generate highly realistic and often deceptive synthetic content such as videos, images, or audio recordings. An example of deepfake creation model could be encoder-decoder model. The encoder-decoder model feeds original face A to the encoder, and later latent face is generated, which in turn is fed to the decoder, which shows the reconstructed face A. Latent face refers to the encoded representation of a face obtained by the encoder part of the model. It is a numerical vector that encapsulates the critical information about the input face, represents a compressed form, the identity, expressions, and other attributes of the face. Same process is followed up for the original face B. Then for creating deepfake, again, original face B is fed to the encoder, but this time, the generated latent face of B is fed to the decoder A instead of decoder B, which basically reconstructs face A from face B as shown in the diagram. Like here, if we see, the face A is fed to the encoder and latent face A is generated, which is again fed to the decoder A. And we have a reconstructed face A from those features which we had extracted, and same process is followed up for original face B. But now if we take original face B and feed it to an encoder, but when the latent face B is generated, we use, instead of decoder B, decoder A. In this case, reconstructed face of A from B is generated. Now, defect detection. Defect detection refers to the process of identifying whether a piece of media content, such as video, audio recording, or image, has been manipulated or generated using defect technology. Detecting defects is a challenging task because these manipulated media often look highly convincing. However, there are several methods and techniques used to identify and detect defect content. Firstly, our traditional method, that is human expertise, which we earlier used to use before deepfake, where we also had some deepfakes generated without using deep learning, like simply cropping a face of a person and replacing with the other person's face, which we could be analyzed for with visual inspections, like if we see something odd in the face, or audio analysis in case of videos. Forensic analysis could also be done, like inconsistencies in facial features, inconsistent lighting and shadows in the images or the video, or inconsistent audio and lip sync. Now, moving towards the machine learning and AI, we use defect detection models, feature extraction, and defect datasets for doing this. Now, we'll move to the literature review, which I have reviewed in my review paper. If we look at the first paper, which actually emerged in 2018, was given by Guerra and Dell, they basically proposed a detection model, which was proposed utilizing a basic architecture. They suggested that a temporal aware pipeline to recognize if videos are bogus or not. This model used a convolutional neural network to acquire frame level information. This information was then employed in the training of the recurrent neural network, which can, in again, access all the videos, assess all the videos, and they can identify if the videos are fake or not. So they had a high accuracy, but the problem was that the data set was really small. Like, as you can see on my screen, that there are only 600 video data set. 300 of them were deepfake and 300 were actually taken from the Hollywood videos. Then in 2018, another paper appeared by Lee and Liu, and they used dataset UADFV and defect emit dataset. And that the
Sorry to interrupt, ma'am. You have 1 minute left to conclude.
okay.
You can tell all the observations that you have,
Okay,
gone
ma'am, sure.
through
I'll
this
just
literature
tell the
review.
observations of all the papers
Okay.
that I have, and along with that, I'll tell you the research gaps as well. In actual, like, I identified all the 26 papers, and then different data sets all used. Like, I have number of deepfake videos in each data set, and number of real videos, and the year that they were published. Then the number of data sets used in the paper that we have taken under review.
Excuse me, you have not used recent paper till 21 you have?
Till 2023, I've taken up, ma'am, from 2018 to 2023.
Okay, okay.
Yes, ma'am.
You have taken.
Yes, ma'am. And
In this table, I am not able to see.
wait a second, ma'am. You're talking about this, ma'am?
No, next.
Next, okay. You're talking about this, ma'am. Ma'am, actually, I have taken up all the popular data sets which are mostly used. So, ma'am, these data sets were actually published earlier, and till now date on, also these data sets are mostly used. Like the famous data sets, we can call out benchmark data sets.
Okay.
Yes, ma'am. And ma'am, if I'll show the number of publications done using these data sets, mostly we use face forensics data set till now date, although it was published in 2018. And after that, DFDC and CelebDF are more commonly used. And then I'll just move towards conclusion and research gaps. While the different models perform well on benchmark datasets like Face Forensics Plus Plus, DFDC, CelebDF, etc., having high accuracy. But when the detection model is tested on wild defect dataset, the accuracy decreases. The thing is that with wild defect fake datasets, more real videos are used as compared to other datasets. That's why the accuracy decreases. So research needs to be done in this sector more, where we can use wild defect dataset and explore more options in that. And there's a reoccurring research need, however, is the necessity for resilience against changing defect generating methods. Like currently, if also we have seen in news that many cases have appeared where actual actresses got their videos viral, having doing things that they were not actually doing. So we need to employ applications in real life and real-time detection and adapting to developing deepfake approaches. Furthermore, the creation of explainable and interpretable models for deepfake detection is a promising field for study should be pursued. And limited exploration of hyperparameter optimization techniques hindering the development of more robust, effective detection models is needed. Thank you, everyone. If you have any questions, please ask.
Okay. That's
And
good.
these are the references of the papers which I have in total used, 35 papers, and thank you.
Okay. Next presentation.
Now I would like to call Emmy Joyce Sukandam for the paper title An Improved Method of Phishing URL Detection Using Machine Learning.
Hello, sir. Am I audible?
Yes, ma'am, you're audible.
Uh,
You may start with your presentation.
Good morning, everyone. So the presentation title for my topic would be an improved method of phishing URL detection using machine learning. The introduction is, we all know that phishing is one of the popular attacks in which the attackers deceive people into revealing sensitive information, and most of the MNCs and organizations have fallen under this trap of phishing, and it has affected a lot of people. And it is also a major challenge in this technology. The survey shows that as per the FDA, 57% of organizations didn't have phishing mitigation techniques, and they have to deal with a lot of consequences like credential compromise and ransomware. So in phishing, URL is the first thing to detect, to analyze if the website is a phishing or not. And we all know that an URL is, it allows the way to access information from remote computers or web servers. So as for the latest trends, we see that some of the phishing attacks and the brands which were affected more were Microsoft, and the SaaS companies and the webmail companies were affected the most. And we also see that the trend has been on the rise. The literature review I have done covers most of the literature. It gave me an insight, and it benefited me to cover most of the research gaps. Some of the research gaps which I had found was the use of data sets, the repeated data sets, and it could not detect new malicious URLs. And or sometimes there were large number of features extracted, due to which it was time consuming. So some of the insights which I've also got from the paper were to a need for innovative solutions, an innovative and simplified solution for the detection technique. And most of the papers showed that ML models were very effective, and it has also benefited me in this paper. So the problem statement which I have taken is, although there are several techniques to detect phishing URLs, attackers keep finding new ways. The new ways to evade all these, techniques and attack the organization. So some of the traditional methods are email gateways, installation of URL plugins, phishing URL plugins, sandboxing. But these are becoming legacy methods. So this paper focuses mostly on finding an improved method in detecting the phishing URL using URLs, and we are applying machine learning techniques for that. Some of the objectives which I have covered is, I have identified a suitable machine learning model. That is one of the objectives, and then I have recognized the contributing features using feature extraction, and the DNS records is one of the target variables which I have used. Most of the papers have not focused on DNS records. So I have used that as a target variable, and it has also plays a very significant role. And then later I have created a simplified web interface to show a demo of the important features and how the malicious URL is being detected. So this is a methodology. We have collected the data from security repository portal. So basically, this is a portal which contains the real-time and the latest log regarding phishing and URLs, we have taken a list of both normal and phishing URLs, performed feature extraction where we can see the lexical features which have been extracted. The model is being trained, and then 80% of the data is taken for testing, training, and testing, and then we have found the prediction. These are the resources which I have used: software and hardware resources components, ML, and using Jupyter Notebook. And moving on to the implementation. So this is the data set distribution. I have malicious and normal URLs taken, and how the model is being applied on the data set. So this is feature extraction is one of the important role it plays because this decides in predicting the URL. These are the list of features which I have extracted, like character count, number of subdirectories, URLs with HTTP token, domains, port numbers. So these are some of the, although some of the previous papers have more features, I have taken the features in such a way that the malicious URL can be predicted. DNS feature inclusion is one of the important feature here because I have used DNS Python toolkit. Most of the papers does not have this particular feature, and this is very important because DNS is basically used to resolve a domain name into an IP address, and we are using the DNS resolver and the DNS Python toolkit to query the DNS records, and this also is used as a target variable. This is how the data is trained and split. This training set and a testing set is done. Once we have performed this, we have found that random forest classifier has performed the best. And this is the list of all the machine learning algorithms I have used: random forest, support vector, adaptive boost, categorical boost. I have also made a chart with the differences in performance, flexibility, and all the variables I have used for the programs. And the deployment part is I have taken the model with the highest accuracy, saved it into a pickle file, and it has been we have used Flask app to make a URL where we can showcase all the features which I have used along with a predict button so that we can predict if the URL is malicious or not. So the URL which I used are being converted into binary codes using label encoder. So this is the result we get. If there is one, if the output is one, it is a phishing URL. If it is zero, it's a normal URL. So once we get the output here, we run the Flask file, and this is the website which opens, and we enter all the features here, and we click on the predict button to give the result. So some of the validation I have done is using the confusion matrix, and this is a graph which shows which feature is showing more importance based on the malware or the malicious prediction. In my research, I have found that number of question marks in the URL shows that the URL is more malicious. Similarly, the administrators can find out which URL contributes to more malware or malicious activity. The analysis and results show that random forest has outperformed all the other models with a high accuracy. And this is the result web page which shows that the URL which I have inputted here is a phishing URL. Under suggestions and conclusions, we can improve this model more by extracting content-based features. Currently, I have used only lexical-based features. We can use more content-based features from the URL to keep up with the latest techniques. And this proposed model can also be applied on browser extensions. This model can be integrated with organization spam filter. We can also find a way to apply this particular interface into a more into software, which I have not done.
You have 1 minute to conclude.
Sure. This can also be used as an endpoint security software for small enterprises.
You can conclude by giving the major findings. You can tell the findings and then you can tell the future prospects.
Sure. Yes, ma'am. So the findings is that we have found that the random forest algorithm has performed well, and we can use this model in future research of projects or detecting phishing URLs. That is one of the main things, because all of these are supervised algorithms. So for future scope, we can compare using supervised and unsupervised model. We can use a more balanced data set with a large number of URLs. Currently, I have used only around 9,000 URLs, which are malicious and normal. So we can use a large number for this thing, but provided I have used this in simplified data. So that is it now. Any more questions and feedback, suggestions?
No specific question. How many papers you have used? How many papers?
I have actually gone to complete 15 to 16 papers, but I have taken 6 different papers here for my study, which has benefited me in creating this paper. And I have covered most of the research gaps. Since some of the papers dealt only with emails, I have taken URLs because we find URLs in basically in everything. And yeah.
Okay. Okay. All the best.
Yeah. Thank you, ma'am. Thank you.
Next presentation. Next presentation.
Now I would like to call Johnson. Now I would like to call Sujit Malkar for the classifying chaotic time series using Gramian angular field and convolutional neural networks.
Good morning, everyone. Am I audible?
Yes, sir, you are audible.
Thank you. I'm Sujit Ramesh Malatkar. I'm pursuing my PhD in PES University, Bangalore. The work I'm presenting here is a part of my PhD work. I'm working on the classification of chaotic time series. To understand what chaotic time series, we first need to know what a chaotic system is. A chaotic system is a system where a small initial change in the initial condition will lead to a vast change in the state of the system as the time passes. Here, the emphasis is on the point that even the smallest of the changes at the beginning stage will reflect as very large changes in the entire system after some time t. Now, although the changes themselves are negligible, but the effect they cause are very vast. To give an example, if you look at this animation of a double pendulum, although we have very well-defined physics equation to describe the moment of the bob that is being traced here, but just by knowing the initial state, we will not be able to tell where the pendulum will be after some 10 seconds or 15 seconds. We have to trace the entire path. So in a chaotic system, we have equations that describe the path very well, so we can go step by step. But just by knowing the initial conditions, we will not be able to get the final state. That is one thing. And secondly, any small change in the initial condition here will lead to tremendously different paths taken by the system. Now, to describe the effect of change, we have taken two different the same chaotic system with different initial points. So even the smallest change in the initial point, if you observe here, the initial point is 0.0 and 0.9. The second set is 0.1 and 0.9, and the third set is 0.0 and 0.8. The smallest initial change will lead to a wide difference in the system as time passes. Here we have just changed the parameter of the chaotic system, and even there we can see the change in the state. Now, how do we get a chaotic time series from chaotic system? What we do is we take the chaotic system and we project it over the real axis. So we take any one of the coordinates like x-axis, y-axis, or z-axis, and we just track that coordinate, and that becomes our chaotic time series. The three time series that I'm studying in this system are Henon map, the Tinkerbell map, and the Ikeda map. The Henon map is a time-independent discrete dynamical system. It is referred to as Henon Pomio map or the attractor also. The describing or the guiding equations for the map are given here. So if I know the current value of xn and yn, I'll be getting the next value of xn. That is the n+1 value of x and y. And the uniqueness of the map is controlled by the two parameters A and B. So here, if I, after 200 iterations, if I plot the map, this is what it looks like. This is the x-axis, this is the y-axis, and this is what the map looks like. But if I take only the x component, this is the time series I obtained from the map, from the chaotic system. This is a Tinkerbell map. This is a quadratic map if we observe here, because both x and y axis, x and y components, we take the quadratic component. So again, here we have parameters A, B, C, D. So for every parameter, we get a different Tinkerbell map, but the shape will vary here. But for everything, when we start with a slightly different value of xn and yn, we end up getting completely different time series. So this is the Tinkerbell attractor, and this is the corresponding x-axis of the Tinkerbell attractor. Aikida map is a complex map where we take a complex number, Zn, and what we do is we use this equation to iteratively obtain the next step of the map, and from that we take the real, every complex number can be broken down into two components, a real component and the imaginary component. We have just taken the real component and we have plotted the time series. The literature survey is here. It's a subset of the larger literature survey I have performed for my PhD work. Now here I'm restricting myself only for works that are working on classification of chaotic time series. So these are the authors, the works presented, and these are the chaotic time series they worked on. If you observe, none of the chaotic time series that I've discussed before, the three Henon or Aikida or logistic have been discussed here. So what I'm doing is novel work. The methods used are deep learning methods. They have used multiple deep learning methods. In the EEG data, it's from a medical field. They're converted into Gramian angular field, which is what I'm working on, and use the same with CNNs to classify. And in the celestial data, they have taken data from astronomical observations and use an ensemble of CNNs. I've borrowed the concept of ensemble of CNNs here. And again, here they're using deep learning algorithms in conjunction with 18 pre-trained models. They've taken known pre-trained models which are good for classification, and that they have worked on further. In the last work, they have used feature extraction using deep learning, again in conjunction with the deep learning techniques to classify. So the main work of my, the main pillar of my work is the Gramian angular field. It's a new method. It's to convert a time series into image data and then use the image data to as an input for the convolutional neural network to complete the classification task. So they're used to represent time series in polar coordinate system instead of the usual Cartesian coordinate system. The Cartesian coordinates where time is plotted on the x-axis and that information is on the y-axis. A Gramian matrix is constructed, and that matrix is used as the input for the convolutional neural network. And the Gramian matrix consists of the summation of cosines or the differences of sines. I'll explain this here. So what we basically do is we take a given time series, right? So for every time series, the data point is xi. We calculate, we first normalize the given time series between the values -1 to 1, because the cos function, the trigonometric function cos, it is defined only in, the R cos function, the cos inverse function is defined in the domain of -1 to 1. So first we normalize the data between these two coordinates, that is -1 to 1. And after that, for every single value xi, I obtain the angle phi, right? So this will give me the angle phi. And the length, if you observe here, the distance from the center is the modulus that is obtained by Ti by n. So what time has passed and the total time that is there in the entire time series, we take that and we obtain this. This is not important for us to calculate the Gramian angular field. The Gramian angular field only depends upon the angle. So if I take any 2 points in the time series, x1, x2, I can calculate the Gramian, the value of the Gramian matrix at any given for any given pair as cos of phi1 plus phi2. So from a time series, I will obtain an image like this. So if you've observed here, this was the time series that we had for the
interrupt. You have left 1 minute to conclude.
Yeah, sure. Thank you. So here we have obtained the Gramian angular field images for each of the time series. And then we have developed 4 models, one each model for each of these time series, each of these maps, that is Henon, Tinkerbell, and Aikida. They are binary classifiers. They will only tell whether they are it's a Henon map or not. And then we have built one universal time series where we give it will either tell it's Henon, Tinkerbell, or IDM. We have generated time series of length 10,000 in synthetical method. And from this, we have taken a random subset of 1,000 series and of length 16 each. And each of those 1,000 are converted into Gramian angular field. And out of that, 900 are used for training and 100 for testing. So this is the method. So from time series, we have computed the Gramian angular field, and that we have used to train this CNN and obtain the output. As I told earlier, there were 4 separate models used. 3 of them were binary classifiers and 1 was a general classifier. We give out the output as a particular time series only if both the general and the standalone classifiers agree. So here we take the time series. This is the Gramian angular field. So we pass it through each of the classifiers. So this is the so for Henon, Aikida, and Nikabel. If, for example, the general classifier says it is Henon and Henon also agrees with it, only then we will give the final output as Henon. If there is any mismatch between the standalone and the general classifiers, we do not share the output. We share the output as unknown. So here, this is the results of the general classifier, the confusion matrix. We have been able to achieve an accuracy of 99.5%. As there are no previous works in these data sets, we cannot compare the results. And these are the individual models confusion matrix. Even here, we have achieved very good results. And the future work is to extend this to multiple systems. There are 13 other chaotic maps which we are working on. So to extend the result to that, and also to use different imaging methods like recurrence plots and Markov transition fields to, but to even improve the accuracy further. So this is my work, and these are my references. Thank you. Any doubts?
I have just a question.
Sure.
Since your data is based on time series,
Correct.
so what is the basic purpose of using time series data with RNN?
You use CNN, ma'am.
Sorry, with CNN.
Yeah.
As if we have so many algorithms that works with the time series analysis. Is there any specific? Yeah,
ma'am. The larger part of my work basically involves that if you give any time series, the way we work on it is we first detrend the time series, we remove the trend, we remove the seasonality, and there's a random component that is left over, and that is what we use to predict the time series, right? So my work, the way I am looking at this, instead of looking at that component as a random component, I am saying that it should be a chaotic component belonging to one of these time series. So the first task for me is to classify any given input into one of these time series. So here I have taken, which I know to be belonging to these 3, and I have classified. But my broader work, what is done is actually on taking a random data set, and that they will be able to classify as one of these time series. That is part 1 of my work, PhD work. The second part involves where for each of these unique maps, I am developing very robust and accurate models for prediction. So once you give me any real life data, and I will be able to classify among, let's say I have 5 maps. I will say which map does this data resemble the closest to. So I will use that map, and I just have to, because I'm already trained the prediction models there already. I just have to retain it very slightly to get my final model. So I'll be saving a lot of time by having pre-trained models for each of these maps. I'll be saving a lot of time to get the final output. So that is the broad part of the entire work that I'm doing. So this is a small subsection of the work that is going into my PhD thesis now.
Okay, this is your PhD work.
Yes, it's my PhD work. Yes. It's
okay. From where you are doing? From
PES University, Bangalore.
Achha, okay. Very nice presentation.
Yeah, thank you, ma'am.
Yeah,
Any other
all
doubts?
the best. No,
thank you, ma'am.
All the best.
Thank you, ma'am. Thank you.
Now I would like to call Johnson for the paper title Attitude Control of Satellites with Reaction Wheels and its Formation Keeping. So,
good morning, sir. Let me share my video.
You may proceed with your presentation.
Yes. Sir, is it viewable?
Yes, sir, it is visible.
Okay. Okay, good morning. I am Dr. Johnson, doing my postdoctoral fellowship in the University of Kerala. I am presenting this topic on behalf of my team. My topic is actually the satellite formation flight control. So this topic is from the control system perspective. So you know that the satellites are moving either in single or in a formation. So the research on the formation of satellites and its flight is older, or it is actually a recent research. So why we move to the formation is because we have to reduce the cost and the reliability, as well as the efficiency of the system will be more in a formation flight. So as well as the spatial image and data, we can capture more as compared to a single satellite, and higher resolution is possible with this system. So how to do this? And we use the Hills or Clausius-Wiltshire equations for the analysis of this system of satellites. So it has a separate coordinate system. A rotating coordinate system is there, in which I select two satellites. One is known as the chief and the other one is the deputy. And as compared to these two, or relative between these two, there is a circular coordinating or rotating system. And the orbit is in a low Earth orbit, that is around 500 kilometers from Earth. And I apply, or I recommend, a perturbation, that is the J2 perturbation. It's actually related to the shape of the Earth. The shape is that in the polar region, the radius is less as compared to the equatorial radius. So that effect will actually affect the motion of satellites around the Earth. That effect is actually taken into account. And first, I do the attitude modeling. Attitude modeling means the orientation of a spacecraft with respect to the coordinate system and how this attitude can be controlled. For this attitude modeling, there are various types of actuators are there, like reaction wheel thrusters, magnetic actuators, momentum wheels, etc., out of which the reaction wheel is selected due to some special reasons. And in this reaction wheel system, actually it's a DC motor, and its electrical diagram is shown here with some equations are there. And a particular plant dynamics is selected, the attitude angle with respect to the reference angle. And I applied the PD controller, partial derivative controller here. And some equations or some terms have to be satisfied for applying this PD control. That terms or that references are shown here. So we can do it. It can be easily possible to control the system with the PD controller. And now coming to the formation keeping, the effect of J2 is introduced here. The satellite motion, the perturbing accelerations and velocity, vector, everything equations are shown here. And here you can see the classical orbital elements are in this diagram. There's a normal orbital plane or equatorial plane is here. And two other orbital planes are shown. One is of a chief satellite and the other one is the deputy satellite. The classical orbital parameters are also here. And AE, omega, W, theta are the classical parameters like semi-major axis, eccentricity, inclination, random, RAAL, right ascension of ascending node, argument of perigee, and the anomaly are the classical parameters. And these equations actually the effect or the change of these terms due to the J2 effect. And I converted this orbital frame into the celestial frame so that the exact position and its velocity of the two satellites can be easily detected using this conversion formula. And now coming to the simulation or result part, you can see in this that the change in the parameters of semi-major axis, eccentricity, etc. during one orbital period is shown here. And you know that except the RAN means the right ascension of ascending node, it has a mean change. All other variations are 0. Its mean value is 0. So that means that the J2 effect is predominant in the random ascending node. It is actually nothing but the angle between the vector through the vernal equinox and the point at which the satellite passes the equatorial plane or the ascending node point. So it is simulated well. Actually, this is that particular session. You can see all other variations are 0, nil around this particular orbital period. And so this is actually its value is not 0, some different value. And for the deputy satellite also, you can see this variation. And
Sorry to interrupt, sir. You have left 1 minute to conclude.
Yes, sir. Okay. So now I am coming to the core point. So from this, you can see this RAN variation, how to minimize it. We apply some thrust to the vectors called thrust control so that it can be easily removed. So this some results are here. You can see the relation between the distance in different planes like X, Y, X, Z or something. This is actually just a near circular orbit using this Closey-Wiltshire equations. And I calculated the delta V, that is the impulse thrust required to overcome this RAN effect using this equation. And I got actually a value of 25.83 meter per second. And this is almost similar to the this value plotted from this graph. So they matches well. And the next part is the solution of the modified Hills equations. That's actually I have done in my own way using some analytical methods. And I have got solution of these modified Hills equations. Yeah, and finally, the contribution and the conclusion is that the formation model simulation has accomplished. The J2 effect is detected, the effect is identified, and the impulsive control is calculated. And the contribution, in a nutshell, we can say the impact of Earth oblateness on the formation flight between two identical satellites in terms of change in classical orbital parameters is simulated. The impulsive control magnitude required to minimize the actual drift from the original trajectory is calculated. The step-by-step solving of the modified Hills equations has been performed. Thank you.
I have a question. Is there any impact of gravitational force?
Yes, ma'am. There is such effects are also there. Like since the satellite is moving in the low Earth orbit region, that effect is also there. And also there is a aerodynamic drag is there due to the atmospheric effect, and there is a solar pressure effect is also there. But I have taken into account this only for the simulation purpose. All others are there. Sure. Yeah.
Yes. But if we want to calculate it in the size, then in that case, we need to work on
that also.
Yes, sure. I have only selected part of that, and the research is going on. And I will select other parameters as well.
Definitely. Very interesting topic and
Okay,
very nicely presented.
thank you.
Thank you. Next presentation.
Now I would like to call Priyanka Patel for a paper titled Demystifying Complex Algorithms, a Visual Guide through the DSA Visualizer.
Dear author, kindly proceed with your presentation.
So moving towards the next presentation by Mr. Shaswat Sawana for the paper title Farm Sage AI-driven solution for agriculture with focus on terrace farming. Mr. Shaswat, you
Yeah,
can proceed with your presentation.
yeah, I'm presenting my screen. Is my screen visible? Hello, is it visible?
Yes, it is visible.
Krishna, would you like to start?
Yes.
Hello.
Dear presenter, please proceed with your presentation.
Yeah. Okay. So yeah, I have my teammate here with me. He'll be co-presenting this presentation with me. Krishna, you can proceed. Yeah, you are audible.
Financial institutions or some business institutions, but it's always late when it comes to agriculture and related fields. So our aim is to bring the advancements in technology.
Can you please speak some louder? Your voice is not audible clearly.
So your voice is being too low. Can you speak aloud?
Hello. Hello.
Yeah, you are audible. You
Yes.
can continue.
Yeah. So our goal is to bring just adjust the mic. Okay, so our goal is to bring the advancements in machine learning and deep learning to agriculture side. So our application is a suite of AI tools. It assists the farmers right from helping what crop to select and what crop to grow and what fertilizer to use and early stage detection of diseases, crop diseases. And later these models can also be used for terrace farming, where some urban enthusiasts are trying to grow some terrace gardens and etc. So, yeah, this is the base of our application. Yeah, we can go from this slide. Shashwat?
Yeah, I'm already on the next slide.
No, the next slide.
Okay.
So how this will be useful for farmers is when a farmer in villages, we all know that they depends on local suggestions or the nearby farming centers. But this application provides data insights based on what crop, like
the soil parameters, nitrogen, the phosphorus content, and the humidity, etc. Based on all that, they'll be provided what suggestion of what crop to grow, and later stage, including these soil parameters as well as what the crop parameter, they'll be suggested what fertilizer to be used for that particular crop in that soil. And during the process, they will also be help with early stage detection through a CNN model. They can take a picture and they can identify the disease. Based on that, they can use some kind of pesticides, etc. Yeah. So that's how it will be useful for the farmers. And when it comes to terrace farmers, like we are mostly the urban people who are like planting gardens in their balconies, etc. They don't know much. So we are providing some basic content like what kind of soil to be used, what kind of conditions to be applicable for that particular crop to grow, whether it's a small tomato plant, whatever it is, like small things, etc. Next slide. Sure.
Yeah, to continue with the presentation, I'll be taking on from here. The existing systems, as you can see, we have considered research works that are recent works from 2022, from 2020 to 2023. We have various models that have different use cases, such as crop recommendation systems and fertilizer recommendation systems, based on various algorithms such as SVM, naive Bayes, IoT, and Arduino, etc. The research lag is in the terrace farming sector, where there is only analysis and theoretical work. There hasn't been a lot of practical models based on terrace farming. So that is what we were focusing on, focusing our model on. Yeah, the problem statement of our main research is at assisting farmers right from sowing to the growing stage, and act as a direct aid to the farmer throughout the entire lifespan of the crop. Our main objective is to correctly assist farmers and make the process of growing crops and taking care of them less manual. As you can see, there's a lot of manual intervention these days in many parts of India. With the usage of AI/ML, we want to reduce this manual load to assist farmers right from sapling to the mature crop. Yeah, so what is the innovation in our idea? We have a multi-model approach. So our research or our product, Farm Sage, combines four different distinct deep learning models, each addressing a critical aspect of farming, right from crop selection, fertilizer guidance, disease identification, and terrace farming advice. The next is agricultural advancement. Farm Sage represents a significant advancement in the application of deep learning to agriculture and urban farming. It leverages cutting edge technology to make farming practices more sustainable, profitable, and accessible to a wider audience. Efficiency and productivity. Farm Sage's suite of decision facilitation tools enhances efficiency and productivity. And the last thing that is unique in our model is the terrace farming advisory model. The terrace farming advisory model caters to urban dwellers interested in farming on rooftops and terraces. It provides guidance to the best soil types and contents for vegetable growth, making urban farming more accessible and productive. Uh, yeah, the scope. The scope of Farm Sage extends to both conventional agriculture and urban farming, making it a very versatile tool for various users. It empowers farmers, gardeners, and urban dwellers to make data-driven decisions. TerraTune's applications encompasses improved selection, efficient fertilizer use, disease prevention, and terrace farming guidance. Yeah, I would like Krishna to continue.
So yeah, the proposed system, as I've mentioned earlier, it consists of four modules. First is crop selection, and the second one is fertilizer guidance system, and the third one is disease identification, and the fourth one is terrace farming advisor. For crop selection and fertilizer guidance, we are using feed-forward neural network. We are using dataset we took from Kaggle, and for disease identification, we are using a CNN model. It's a plant village dataset we are using for disease identification. And for crop selection and fertilizer guidance, we have also augmented the dataset using smoke augmentation. And for terrace farming, we have gathered data, we have scraped the data from internet. As of now, it's more of a particular, we don't say as we are using terrace farming, we are not using any particular model, but we are using the scrape data and are advising based on that. Yeah. So these are the features we are using in crop selection: nitrogen content, phosphorus, potassium, temperature, humidity, etc. These are the parameters for the models we are using in the training strategies. And for optimization, we are using RMS prop. So this particular optimizer is for each and every parameter, there will be individual focus on each and every parameter based on historical gradient. The next. It's a similar kind of model for fertilizer guidance system as well. And terrace farming advisory, as I mentioned earlier, we are using scrape dataset. And we are using.
Sorry to interrupt, sir.
Yeah.
You have left 1 minute to conclude.
Yeah, sure. Shashwat, can we skip to next slide? So this is the architecture. We are encompassing all the 4 modules inside a single application. And we are using same dataset for crop selection. And along with the crop selection dataset, we are using some additional parameters in fertilizer guidance. And for disease, we are using a CNN. Here, the input is an image. And for the first 2 models, the input are the parameters in a text format.
Yeah.
So this is the front end.
Yeah, so to continue, this is the front end. We have used the Streamlit library from the Python and made a basic interface. As you can see, there are 4 different modules that the user can go upon, and we can provide different parameters in the crop selection module. And as you can see, there's a suggest crop button that will suggest a suitable crop based on the current conditions. Next, we have fertilizer recommendation model. Same thing, we recommend the fertilizer based on the current conditions. And the model is trained upon the data set that my partner mentioned before. We have the disease identification system where we can drop an image and check whether the certain part of image has a disease or not. The terrace farming advisory system, we can choose whichever plant we want and display the characteristics, and then the urban user can check whether those characteristics are similar to his current place or not, whether his place is suitable for growing the crop or not. As far as the result analysis is concerned, we have the crop selection model is a 95%, fertilizer guidance model is 95%, and the disease identification model is still that something that we can scale upon. It is still at 66%. Yeah, as you can see, this is the accuracy proof. We have the different accuracies for the different models. These are some of the few references that we have taken for our research. Yeah, thank you. And if any doubts, please ask. Actually,
what is the one limitation of your work? Because you have developed all the things in one system, right?
yeah.
Yes.
How you can improvise that?
So as of now,
yes,
we are hosting it on Streamlit. So maybe we can make it much more simplified, and we can extend this parameters and the diseases. As I've said, we are still achieving around 66%. We are trying to improvise that, adding some more data, collecting through web scraping and
maybe
etc.
you can take one module at a time and you can work on that. When
Yes,
it
ma'am.
gets over, then you can start with the otherwise the concept is very good.
Yes.
Yeah.
Concept
Okay.
behind your this work is very good, but at a time for the implementation perspective, you can take one and then you can later, because there are so many parameters involved in each and every category.
Yes,
Yes, ma'am.
So
yes, ma'am. So the next step,
what is
the
my
next,
suggestion? Yes.
yeah. So the next step will be making it into a complete product. Go step by step and improvise each model, and then go ahead. Yeah, like you
So
told.
as of now, we have made a more of a prototype kind of
Yeah,
thing, but
this is
it
a
do work.
prototype.
Yes,
It
it's
do work on
definitely.
real-time data. We are
Yes.
trying to improvise one by one model performance by adjusting parameters and all. So
Yes, ma'am.
we'll definitely do that.
Because there are various parameters when you talk about selection of the different fertilizers or the disease prediction, because again, this is one complete module.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So maybe some of you can work on one, or then some of you can
Yes, ma'am.
can divide that thing.
Sure.
Yes, ma'am. Definitely.
Otherwise, the concept is good.
Okay, ma'am. Yeah. Thank you.
Okay, all
Can
the
I?
best.
Thank you.
Yes, ma'am. Thank you, ma'am. Can I stop presenting my screen?
Yes,
Yes.
sir.
Next presentation.
Now I would like to call Priyanka Patel for the paper title Demystifying Complex Algorithms, a Visual Guide to the DSA Visualizer. Ma'am, you can proceed with the presentation.
Am I audible?
Yes, ma'am. Your voice is a little bit low.
1 minute, sir. Is my PPT is there?
Acts a hybrid deep learning approach. Ma'am,
Hello, am I audible?
yes, ma'am. You may proceed with your presentation.
Let me share my screen.
Yes, ma'am.
Is my screen visible? Hello?
Yes, ma'am. You're audible.
Okay. Hello, everyone. I'm Maisha Mahajabin. I'm an undergraduate student. I'm here to present our paper, Unmasking the Botnet Attacks, a Hybrid Deep Learning Approach. This is the outline that will be covered throughout our presentation. Now, starting with the introduction. As we know, our IoT device is becoming more integrated. So this allowing potential risk and vulnerabilities that is also increasing, which allows bugs to easily exploit the botnet. So it lacks security architecture, posing valuable information danger, and are always updated to the timely manner. So for that reason, deep learning algorithms can provide a strong defense against botnet attacks and strengthen the network security and improve the botnet detection precise and effectively. So that is why we are presenting a hybrid approach to detect botnet activity that are combined deep learning algorithms with network traffic analysis. Our objective of this is to spot suspicious activities that are a sign of botnet operation, and also to offer a defense against the botnet attacks by securing the network and guiding the sensitive data. So moving to the next part. For literature review, I am taking the important reviews. And the first one is there is the author who applied bot IoTs that can identify security vulnerabilities in IoT networks using LSTM and GRU and with basic RNA. And authors also use machine learning algorithms, and there is one paper where Red3 plus SVM outperform a state-of-art technique with great accuracy. And smooth DRNA algorithm demonstrated really a high detection rate and low false positive network, which is great. And this is the currently in use technologies and algorithms. So moving to the next part, this is our workflow of the proposed model First, we took a data set and we preprocessed it by data cleaning, data balancing, and for feature selection, we used K-based selector, variance threshold, and recursive feature elimination. After that, for classification, we used LSTM, GRU, and Gaussian naive Bayes. And lastly, we proposing our hybrid model, LSTM plus GRU. For dataset, we used UNSW 2018 IoT botnet dataset, which combines regular and various attacks, which includes network traffic and DDoS attacks, OS service scan, key logging, and etc. We use the dataset 10-based training testing split to evaluate algorithms performance, and it needs to mention that our dataset is highly imbalanced. There are only 370 instances of normal traffic out of 29 lakh samples of data, which also included 16 input attributes. We used 10,000 records with 10 features each, and the division was used for both training and testing. Okay, so moving forward, for data preprocessing, I already said that we used K-based selector, variance threshold, and recursive feature elimination. By using this, we are selecting the top 10 feature that could focus on the eliminating that are creating big impact on our performance of our model. For data sampling, we have used our dataset as our dataset contains high level of irrationality. In order to reduce that in dominating class and balance of our class distribution, we use random classification, random sampling, sorry for that, random undersampling. The majority class is to match the size of the minority class. So following that, we used ADASYS, a smart variant that gives the minority class gives minority classes samples which are more difficult to comprehend with the high weights. And this is our proposed model. In our proposed model, we used LSTM layers and GRU layers with the dropout of 0.3 and batch normalization sites. This is our result and discussion. We used 4 different type of methods. From that, LSTM and GRU hybrid model giving the best result and outperform the others. This is our performance analysis, and we can see that our best overall accuracy is 99%, and we can see some variations in the value loss, but the training loss almost remain constant. This is our confusion matrix. I want to mention that one of notable gain is to our hybrid model is able to reduce the false positives. In traditional methods, frequently flag resume traffics are suspicious, causing unnecessary disturbance and user inconvenience. Our deep learning algorithm allow us to distinguish between the normal network and the malicious botnet behaviors, reducing the false alarm and improve our whole system. This is our comparison with other existing techniques. We took approaches such as DNN, ANN, LSTM, GRU, and DNN. And we can see our model is giving almost nearly the best results. So I'd like to conclude my presentation here by emphasizing the efficiency of deep learning algorithms in botnet attacks. And our hybrid model is able to identify the known botnet attacks and successfully interact the ongoing threats, thereby stopping the attacks for further spreading. And because our model is enhanced realization against dynamic threats,
which also can minimize false positive with the adaptation of responses and coordinate across network component. Its adaptation to the dynamic nature in the smart world can be valuable. And this is the references we have used in our presentation. And with that, I would like to end my presentation. Thank you.
What are the future prospects?
So we couldn't include all of the data set because of this resources. So we like to include that in a real-time data set and real world applications.
Okay. Okay, nice presentation. All the best.
Thank you, ma'am. Can I stop my screen sharing?
Yes, ma'am.
Thank you.
Now I would like to call Dr. Priyanka Patel for the paper title, Demystifying Complex Algorithms, a Visual Guide to the DSA Visualizer. Ma'am, you may proceed with your presentation.
Yes, dear, I am audible. Am I audible to you?
Yes, ma'am.
Allow me to sharing the screen. Hello. Allow me to share the screen, please.
No, you are already allowed. Please share.
No, there is two options, one participant at a time.
Yeah, you can just share the screen directly from the green button that has been
Okay.
already shown.
Is it visible to you?
Yes.
Okay.
Yes, ma'am, it is visible.
Okay. Thank you so much. And sorry for the disturbance from my side. Okay. So the paper title is Demystifying Complex Algorithm, a user guide through the DSA visualizer tool. And the author for this paper is Jeet Matalia, Shreya Katharia, and Priyanka Patel. So the content of the paper is as below: introduction, problem statement, proposed system and scope, feature of the tools, project flow, and the conclusion. So we have designed this presentation as per the what we have thought of the particular paper and the problem solution. The aim of this particular tool is to understand the algorithm, which is help to understand the data structure and related to algorithm. So the DSA visualizer aims to simplify the understanding of complex data structures and algorithms through its user-friendly feature and interactive approach. So basically, we are providing the step-by-step clear-cut algorithmic execution throughout the tools and the applications, which elucidates the purpose and outcome of the each operations. So one can learn, the student can learn by themselves also. They can self-motivated to learn each and every concept of the data structure, and they know how algorithm works for the sorting and searching. Now these visualizers are also offer the performance analysis tools such as matrix for the time and space complexity. So we can also calculate both time complexity and the space complexity of each algorithm. We can see the insights of algorithm efficiency in the different scenario. You can provide your data own data to the tool, and it will provide you the whole graph and how the example is grow, how the graph is designed. You can see that. So basically this visualizer aims to bridge the gap between the theory and the practice or the practical, and making complex data structure and algorithm more accessible, engaging for the users. Over here we are using users for the student, those who are understanding the data structure at very first time or learning the algorithm for the searching and sorting. So what are the main features of the applications and the tools we have designed? So the main application to incorporate several user-friendly features and to enhance the learning experience of the user are most prominent feature of the applications are to provide animations to those algorithm, synchronizes code with visualization, step-by-step information, data representation means the theory part is already given aside. So one can read and one can see how the algorithm is traversed, one can see the graph, one can see everything, how the example is going on and how you can reach to the bottom node to the search node, which enables user to explore and comprehend the inner working of the various algorithms, particularly in the area of searching and sorting. Our application provides customizable options which allows user to adjust animation speed, color scheme also and visual elements also, and focusing the personalized learning experience so they can understand it better. And performance analysis tool in which we are providing the matrix as earlier said, the complexity for the time and space we have already included in that. So it will, you can provide for the different scenario also. This application support various sorting searching algorithm, allows user to compare and contrast different approaches. So one can understand at which problem statement, what type of data structure is required, what type of searching algorithm or sort of sorting algorithm we need to apply based on the problem statement. And the whole design is very responsive, so it ensures the accessibility of access device, enabling user to interact seamlessly with visualization and both desktop and mobile platform. It also provides error handling mechanism. We also provide the feedback features for the users to understand what type of data they need to feed for the particular algorithm. And we can engage the students or the learner for more time on to understand the data structure. So basically, till the date, the application is providing data structure. We have included array, linked list, stack, queue, and trees. For sorting algorithm, we have bubble, insertion sort, selection sort, merge sort, quick sort. And for searching sort, we have designed binary and linear search. And for other algorithms, we can go for the base for search, best for search, Kruskal, Dijkstra, and Prem's algorithm. So basically, all the data structure is here, all the type of algorithm for sorting and searching. For basic understanding, we are providing with the theory and with the graphical representation, so you can learn why you are reaching to particular node. So we have started this particular uh, application to understand the student why they are lacking to understand each and every concept. So the purpose to design the application or website to feed the student a very perfect and clear knowledge. So basically this start as a designing and implement algorithm, first to understand the algorithm, then prepare the basic source code and simulate and debugging. If the algorithm is not working well, then we cannot feed onto the website. So we need to clear out that the algorithm is work fine. Then we have provided GUI and we'll again simulate it, and then we have applied into the application. Now, what is the purpose of to create this particular website or application? The purpose of the model to design DSA visualizer application aims to enhance user interaction and educational engagement by providing a seamless flow that empowers user with enhancement, comprehension of data structure and algorithm. The main idea is to self-learn. It is incorporate the importance of diverse data structures such as array, linked list, trees, enabling comprehensive visualization, and it is very flexible to provide input to the
Sorry
particular
to interrupt,
template.
ma'am.
Yes.
You have left 1 minute to conclude.
Okay. Okay. So you can also provide data values to the algorithm and visualization options, and we can check. We can see the flow of the algorithm. We can see how data is traversing, how nodes and edges are there. Then these are the what are the main feature is the user can learn by themselves the number of time they can see the animation, control the animation speed, they can control the color scheme, so they can learn in their own way. So the model is emphasized on user centric approach and first aim is to one student can learn by themselves. That is what the target of this particular paper. So glimpse of the visualizer tool, this is what the basic idea of the app or the website we have chose. You can see our sorting and data structure and all the algorithm. We can see the color code over there, and we can see the algorithm and the graphics over there. Over here, this is the example of the bubble sort algorithm. We can see the code over there in the Python, in the C and the C++. If we want in Java, we can also provide that. We can see the step at the very left side, and we can see what are the data we have feed in a generate input. We can see, we can limit the speed also. Same way, we can go for the searching algorithm, data structure algorithm, and other algorithm as we have discussed, Dijkstra algorithm, Prim's algorithm. Okay. So result analysis. So it plays a pivot role to evaluating to optimizing DSA visualization system. It involves comprehensive examination of collection data, measures the system alignment with the predefined goals. This phase encompasses quantitative metrics, user feedback, overall impact of assessment, providing valuable insights for system refinement and optimization. By analyzing performance metrics, includes time and time complexity and space complexity. So it is reliability and functionality, ensuring that meets specific requirement and the functions of the understand and they can learn well. So the basic idea is to learn and educate the user and clarifying the complex algorithm in a very easy way. And if they want to learn the language, they can learn that through the software, and they can see the nice visualizations, and they can see the advanced features also. We are also providing quizzes and exercising, so they can check their score also, that they are learning in a proper manner or not. These are the reference in which we have learned about the algorithm, how to calculate the complexity and all. And these are the website through which we can learn how to design the particular website or the application. Thank you.
Overall, the idea behind your application is very nice, very interactive. And there is a concept of virtual labs also, and it is, it is available on IIT Bombay platform.
Yes, ma'am.
So how is it different from that, your application?
No, ma'am. We are not focusing on the other laboratory. What is the purpose of that? I want to make my student or my users do very clear about the basic concept behind the any algorithm. Either it is deep learning, machine learning, AI, or you are learning any data structure, any algorithm or any field. First, we need to understand the data structure. So basically, the idea is to understand through the basic, through the end. So we have updated till this particular data structure and sorting algorithm. Then we are trying to, the featureize more options in that. So this is particularly for my university. So we can say that this is for the practice. We can also using the
No.
NPTEL videos, and we are local chapter of NPTEL. We are learning from them or there also. But I know how my student are understanding. So the steps we have mentioned in this particular algorithm, that is based on what we have discussed in the classroom. If those steps are very neat and clean understanding by the thousands of the user, then we can publish for the world that okay, you can understand this better in a very simplest way. In a way, we have thought of the idea.
Yes, that is a good idea. But when we talk of any educational content, right, we must refer some other same concepts also if they are being implemented somewhere else. So
Of
that is
course.
why, yes, that is why I'm talking about that. I know it is for your university, you have created this model for your students, but again, the things can be focused for others as well.
Yes, ma'am. Actually, we have already launched. Means the university. I'm working in Charosat.
Okay.
Has already announced the online courses. So we have that setup. When we are focusing on the website, making application, we thought of for the local users or student only. Now we are on the web. We are offering the courses. We are creating the videos. We are trying to reach to the benchmark uh, level of that the world is doing. Right now I am not comparing, I am no one to compare this particular work with the NIITs or IITs or anything. So that is why I stated that this is for the local users. That is what the purpose we have already, we are learning from them only.
Yes, yes, not comparing, but research is always
Yes,
results
it's
in whenever you give your output, you have to compare with the existing ones.
yes ma'am, yes
है ना?
ma'am,
This is
yes
not a direct product
yes
benefited for your organization. Whenever you are presenting your paper in any conference, you have to compare.
yes ma'am, okay ma'am, next time we'll
है ना?
surely do that. Right
Definitely,
now
because
yes,
it will definitely give some weightage for your product or your
okay,
process.
okay,
Yeah.
okay ma'am,
Otherwise, the
thank you so
concept
much.
is very good,
Okay
and
ma'am,
yeah, and you presented very well.
thank you ma'am.
Yeah. Okay, thank you. All the
Thank
best.
you, thank you ma'am.
Thank you, ma'am. On behalf, I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 8th version and the previous 7 version of the conference. We will be happy to have you in the 9th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2024. I also thank our session chair, Dr. Ruchananda, for chairing the session.
Thank you ma'am.
Thank you.
This is a
Thank you.
token of love. This is a token of love, appreciation to the chair on behalf of Team SmartCom 2024 and Global Knowledge Research Foundation and partners. Ma'am, we would love to hear the words of knowledge from your side.
Thank you. Thank you so much, Harsh, uh, for this very interactive session. Yet all the papers were very good, and I think all the participants must have uh, shared the knowledge, and they must have got a very precise knowledge among all the topics which were covered. Mainly, um, the topics were related to all the topics majorly, and they were focusing on machine learning and on different areas like time series analysis and deep fake video detection to heritage sites using this quantum computing and the use of machine learning, DSA visualizer, botnet attacks. So I think all the participants must agree on my part that this was a very fruitful session. My sincere thanks to GRT for organizing such events time to time, and thank you all. And
Thank
all
you
the
ma'am.
best to all the participants.
Thank you ma'am.
Thank you for your valuable presence. I request all of you to switch on your cameras for a quick snapshot of the virtual conference. I again request everyone to please switch on their cameras for the quick snapshot of the virtual conference. Thank you, everyone. Stay
Thank you,
safe.
everyone. And thank you, Ruchi ma'am, once again.
Thank you. Thank you.
Once again, thank you, everyone. Stay safe, stay connected.
Thank you. Thank you.
Thank you all.